Introduction to Statistics, Chapter 6, Discrete Probability Distributions, Section 6.2, the Binomial Probability Distribution. The binomial probability distribution is a discrete probability distribution that describes probabilities for experiments in which there are two mutually exclusive or disjoint outcomes. The two outcomes are usually referred to as success and failure. The main idea behind a binomial probability distribution is to determine the probability of X successes out of N trials when success and failure are the only two possible outcomes. The criteria for a binomial probability experiment. An experiment is a binomial experiment if the experiment is performed a fixed number of times. Each repetition of the experiment is called a trial. The trials are independent. This means that the outcome of one trial will not affect the outcome of the other trials. For each trial, there are two mutually exclusive outcomes, success or failure. The probability for success is the same for each trial of the experiment. Some notation you should be familiar with. The lowercase n is used to represent the number of trials. The lowercase p is used to represent the probability of success for each trial. Lowercase q is used to represent the probability of failure for each trial. In any binomial experiment, p plus q equals 1. Therefore, q would equal 1 minus p, and p would equal 1 minus q. The random variable x is used to represent the number of successes in n independent trials of an experiment. Therefore, x could equal 0, 1, 2, 3, all the way out to n. Now, the binomial probability may be found using three different approaches. First, using the binomial probability distribution function. That's p of x equals n combination x times p raised to the x power times 1 minus p, which is q, raised to the n minus x power. Okay. Now, this was the first approach used, okay? And the formula is given in the book, and a lot of times they want you to use the formula, but you don't need to use the formula with today's technology. So if you want to interested in learning more about the function and how it was derived, how it's used, read pages 329, 333 in the e-text. But we will not be using the formula. Now, second was using a binomial table. Now, since the binomial probability distribution function was so time-consuming, a table was created for several of the commonly used n values. Now, you have to remember, these tables were created before the calculator was invented. So, with technology today, the tables are slowly disappearing. As a matter of fact, I don't think there's a binomial table in your set of tables. So, if you want to learn more, you can read it page 333 and 334 in the e-text. But we will not be using the binomial table. Then we can use technology. This is what we're going to use. Now, there are many software packages available that have the binomial probability function built in. Excel, Minitab, StatCrunch are some of the commonly used software packages. To save time and energy, we will be using StatCrunch to find probabilities. You must remember, using StatCrunch is the easy part. Reading the problem carefully and knowing what you are looking for is the main part of the problem. Now, working problems using StatCrunch. First, read the problem carefully. Determine the values for n and p. You need to get this information out of the problem. Second, read the problem carefully. Determine what you are looking for. Now, you could be looking for the probability x is less than some number. You could be looking for the probability x is less than or equal to some number. You could be looking for the probability x is greater than some number. X is greater than or equal to some number. X equals some number. X is trapped between two numbers. Okay? There's a lot of different possibilities, but you have to read the problem carefully to know which one you're looking for. Because if you choose the wrong one, StatCrunch will give you the wrong answer. Third, understanding the meaning of at least, at most, more than, less than, no less than, and no more. There's going to be all sorts of word phrases that you have to be able to translate into an inequality. Less than, greater than, equal to, So let's look at a few of these. Okay, if we look at a few of them, at least 5, what's at least 5 mean? That means greater than or equal to 5. At most 5, at most means no more than 5, so that's less than or equal to 5. More than 5 means just x is greater than 5. Less than 5, x is less than 5. No more than 5 means x is less than or equal to 5. No less than 5 means x is greater than or equal to 5. Between 3 and 8 means x is greater than 3 and x is less than 8. Between 3 and 8 inclusive. Now the word inclusive means you could equal 3 or 8. So x is greater than or equal to 3, less than or equal to 8. And exactly 5 means probability x equals 5. All sorts of word phrases that you have to be able to translate into algebraic inequalities. 4, use StatCrunch to get your answer. Okay, we're going to open StatCrunch by clicking the little question help button on the problem and click StatCrunch. Click Stat on the top menu, highlight Calculator, select Binomial. If not between, be sure standard is white at the top under Binomial Calculator. You can choose standard or you can choose between. Okay, so and then you would enter your value for n, value for p, choose the correct inequality sign, enter your x value, and click compute to get your answer. Now if it's between, then you would click between, so it turns white at the top. Then you would enter a value for n, value for p, and enter a lower value for x value and an upper value for the x. Then you would click compute. Now, using StatCrunch is not as hard as it sounds once you go through it a few times. We will now go through a few examples. Now, on this problem, a binomial probability experiment is conducted with the given parameters. Compute the probability of x successes in the n independent trials of the experiment. So we're given n is 20, p is 0.65, x is 17. So I want the probability 17. Okay? And that, when just put 17 there, that means x equals 17. Okay? They just leave out the x equals. So we go up here to the question help. Click on it. Click on StatCrunch. Now, what did I say in StatCrunch? Now in StatCrunch, you're going to click Calculators and get Binomial. You'll click Stat, highlight Calculators, click Binomial. Now, let me put these side by side again. So if I shrink this one down, snap it to the right, and then okay, this isn't going to slide over. Okay. Because when it opened right in. So, once we open this up, we get this possibility. Now, what I want to do is put the n value in. N was 20 from my problem. P was 0.65. And I wanted equal to, so I click on the inequality, choose equals, and 17 was my answer, my x value. Click compute, so my answer is right here, 0.0322579, and they wanted it rounded to 4 decimal places. So if I round this to 4 decimal places, it's 0.0323. Okay, so I can close this, check my answer, and we're good. Now the next question. This time, n is 13, p is 0.1, x is less than or equal to 4. So I open up StatCrunch. Let me bring this in a little bit. Okay, then I click Stat, Calculate, highlight Calculator, choose Binomial. Now, my n value for this problem was 13. My n value was 13. My p-value was 0.1 if I recall. And I wanted, what? Less than or equal to 4. Less than or equal to 4. Click compute. And my answer is 0.9935. And I wanted this to 4 decimal places. So 0.9935. Come on down. And you're probably easier at moving these things around than I am. .9935. And check our answer. And we're good. Okay, so we go on to the next question. Now, we haven't talked about this yet, so I got to go back to the video. No, we basically have, so let me go back to the problem. Okay, now this time they want you to construct the binomial probability distribution. So this is a little bit different, okay, because you could use the formula on every one of these to develop it, but I would not. That's what he did at the beginning. So we're going to use StatCrunch. So we know the p-value is 6, and we know the n is 6 and p is 0.85. So we go up under StatCrunch. Under stat, hit stat, calculator, binomial. Alright, n was 6, p was 0.85. Alright, now if I change the inequality to equals, and I change this to a 1, unfortunately this is going to be a slow process, because you will have to hit compute, and they want 4 decimal places. So I come over here, enter at 0.0004, go down to 1, sorry, 0.004. So I got to go back up here, take this one out. And then go back over here, put 0 in instead of 1. Start at 0. Compute. So this is going to be now 0.1234. Now remember, 0.0000 is not the same as just putting a 0, because there's a probability of 0 means it can never happen. A probability of 0.0000 means there's a very slight chance, but it could happen. All right, then I change this value to 2, compute, go down through and put all the answers in. Okay? And that's how you would fill in the chart using the binomial calculator. Now, last we want to talk about finding the mean standard deviation. Now, if you're given a binomial distribution, you're given n and p usually. So calculating the mean and standard deviation using your calculator is going to be the way we go. So the mean, which is mu of x sub x, is just equal to n times p. So you just take n times p. And the standard deviation of x, which is sigma of x sub x, is equal to the square root of n times p times 1 minus p. Or you could say it's the square root of n times p times q. Okay, and all that can be done by hand. This brings us to the end of section 6.2.